Today's lesson is called Linear Regression on the Calculator. So in the last lesson, we drew lines of best fit by hand so that we could model bivariate data that had been graphed on a scatter plot. In this lesson, we will see how to use our calculators to find the equation of the line of best fit. This is referred to as linear regression. So if you see line of best fit or linear regression, they mean the same thing. We will work in the first exercise with a data set from the last lesson. So today is really about how, thinking of what we did in the last lesson and how hard it was to find exactly where to put the line of best fit. We know it's supposed to be in the middle, but everyone's going to be maybe slightly different from each other. If we do this on the calculator with a linear regression, not only is it done more quickly, but it's more accurate. We're all working with the same line of best fit and equation of that line to use for predictions and to interpret. So we're going to use the same data set as the previous lesson. A sample was taken of 10 low and high temperatures for a given day in Fahrenheit in the month of April to try to establish a relationship between a day's low temperature and its high temperature. So remember, X was low temperature, Y was high temperature. Today, in this beginning part, we're going to take that same set of data that we did by hand previously and do it on the calculator. So it says, enter the data into lists on your calculator. The low temperature X will be entered into L1. So let's highlight or underline that. And then the high temperature Y will be entered into L2. So up here next to each of them, I'll write L1 and L2 just as a reminder. Now we've entered data on the calculator before. We did this in the one variable portion of statistics. So it's very much the same thing. It's just that L1 is going to be the X's and L2 is now going to be the Y values. So once you're in your graphing calculator, remember the buttons you're going to hit, which are also on your notes as reference, nothing you need to fill in, but that first picture under part A on your notes shows a reminder of how to enter the data. So you're going to hit Stat and then option 1, which is Edit, and then you're going to enter your X values such as 26, then 28, etc. into L1, and then you'll arrow over to L2 and you'll enter 51 and 50 and so on. So at this point, please pause the video, enter your data, and then resume the video to move on with me. Now you've had a chance to enter that data yourself, so you kind of should be looking like me. You've entered both, you're at the end. So now we're going to look at part B on the notes. Part B says create a scatter plot using your graphing calculator. So yesterday we did that by hand. We're going to use the graphing calculator to do that. And then we're going to compare this to the scatter plot you created in the last lesson. So I want to walk you through the steps on the graphing calculator so that you know how to create a scatter plot using your graphing calculator. So from here, we've already entered the data. We need to make a scatter plot. So we want to hit second Y equals, because that gets us to our plots, and we can make different pictures of graphs, as you can see when you look at type there. And obviously we're going to make a scatter plot. So we're going to pick option 1, stat plot 1. My screen looks a little bit different than yours because mine are kind of highlighted at the top. So you just make sure that you enter the number 1 for the very first stat plot like you see in the picture on your notes. And then once you do that, your screen will look like mine, which is your 3 and 4 under part B. So we want to make sure that it's on. Right now you can see mine's off, so I'm going to go up and arrow over to on and hit enter. To turn anything on or off, you're going to go to your selection and hit enter, and it chooses that. So again, if I wanted it off, I'd go over to off and hit enter. I want it on, so I'm going to go over to on and hit enter. The color does not matter. The type is definitely going to be the scatter plot, which should be the first option. So you can see that there. Your mark, I leave as the boxes. It doesn't matter what you choose, but it's already selected and there's nothing wrong with that. And then you need your X list, should be L1. If it's not, remember you can hit second and number 1 to enter L1. When you go down, your Y list should be L2. So as long as all of that is set, then we're ready to make our scatter plot, which is what you're going to see on your notes in steps 5 and 6. We're going to hit zoom, which I know we're used to doing, and usually we're picking standard. We don't want to pick standard anymore. We want to pick option 9, which is zoom stat. So that's for statistics, so it makes sense. So we're going to hit 9, and you will get a picture of your scatter plot. Now, the one that you get on your calculator is a little bit better. You can see me in the bottom left corner, 50 and 25 are in the same place, which is not accurate, but you can see the points overall for the scatter plot. If you want to view and adjust the graphing window, all you have to do is use the window key. So if you went here to window, you could change your X-min, your X-max, your scale, etc. So now you know how to make the actual scatter plot on your graphing calculator. So now we're to the point where we have the data, and if you think about what we did yesterday, we then drew the line of best fit by trying to put it in the middle the best we could. So the step equivalent to doing that on your calculator is running what's called a linear regression. So you're going to run a linear regression on your calculator. That's going to give you the equation for the line of best fit. Make sure you always read the directions of the question. In this one, they want us to round the slope of the line to the nearest hundredth and the y-intercept to the nearest integer. So slope to the nearest hundredth means 2 decimal points. Y to the nearest integers means to the ones place. So on your notes here, you can see the steps for running a linear regression. I'm not sure if you remember this, but when we were in the exponential functions chapter, running a regression was one of the options we had for writing the equation for exponential. So this is very much the same thing. You put your x's in L1, your y's in L2, and if you run the right type of regression, it'll give you the equation. So as you can see in the first portion, you're going to press stat and arrow over to pick choice 4, which is a linear regression, and then we'll be able to pick off our information from there. So I'm going to go demonstrate on the graphing calculator. So if we did zoom 9 again, we'd be at our scatter plot, and we want to run our linear regression. So we're going to hit stat. We are going to arrow over to calculate. We've been here before, but we are going to pick option 4, which is a linear regression. And here it says ax plus b. We know that usually as mx plus b, but that's a linear regression for y equals mx plus b. So that's the one we want to choose, choice 4. Now, once you choose that, you want to make sure you have the appropriate list. X list is L1, Y list is L2. That's where we entered them. So we should be all set, and we can hit enter, and we can scroll up and down to get whatever information we need. So here it's showing me that the equation is y equals ax plus b. It's giving me an a value of 1.10755, etc., and a b value or y-intercept of 21.1786, etc. So they wanted slope to the nearest hundredth. That would be 1.11 because the 7 would bump it up. And then we want the y-intercept to the nearest integer, so that would be 21. The slope we will write as 1.11. The y-intercept was 21. And then we'll write our equation as y equals 1.11x plus 21. So now in the next portion, it says compare the slope you found in the last lesson to the slope from the line of best fit. So we'll do the slope from the last lesson first. That slope was 1.13. So now you can see comparatively, today we have a slope of 1.11, which are pretty much almost identical, but not exact, but very close. So the two slopes are very close to equal. So we did a pretty good job yesterday, but were we completely accurate? No, we're a little bit off. And that's why you can see running the regression just really is so much better than having to do it by hand. So now in part E, it says add regression equation for the line of best fit to the scatter plot using your graphing calculator. Compare this to the line of best fit you created in the last lesson. So once we run the linear regression and we have the equation, we can add the equation to our actual scatter plot and see where we should be drawing it. And I almost would suggest kind of like tracing and picking a point so we can be as accurate as possible. So the steps for adding the regression equation line are here. You can follow those in your notes, and I'm going to demonstrate on the graphing calculator. So following the steps in part E, we'll start again and kind of repeat doing the linear regression. So you've got stat, arrow over to calculate, pick option 4. Remember, you want L1, L2. So we're going to hit enter. All right, so we'll start from the steps on the left. We're going to repeat how to do the regression again. So stat, arrow over to calculate, pick option 4. And this time we want to arrow down to where it says store REGEQ. So we're going to hit the arrow down as many times as we need to get there. It could be 2 or 3 times. I think for me it was twice, you for 3 times it says. And then we're going to hit the VARs key, which is to the left of clear, right there. And we're going to arrow over to YVARs. And we're going to pick option 1, which is functions. And then we want Y1. So we're going to pick option 1. And then we are going to hit enter. And then graph. And it will put the line of regression or the line of best fit right on your picture of where it should be when you create the scatter plot, which is really nice because you can see the placement of it. Now moving on from there, we have to be able to interpret what we have as slope and possibly y-intercept, similar to what we did yesterday. So part F says, explain what the y-intercept of this model represents in terms of the low and high temperatures that are being modeled in this problem. So the y-intercept for us is 21. So the y-intercept means that if the low temperature was 0, the high temperature would be 21 degrees. So the same idea of what we've always talked about at y-intercept. It's what's the y value when x is 0, but interpreting it for the situation. So the next question, G, says a day in April has an unusually warm low temperature of 52. So they're giving us a low temperature of 52, which is unusually warm. What does the best fit linear model predict? So what does the best fit linear model predict as the high temperature? So a couple of things here. They gave us a low temperature, so that is an x value. And when they say predict, they want us to use the equation. So we're going to make a couple notes here. We want to make sure we write use equation. And since they gave us a low temperature, it's an x value of 52. So we get the line of regression or line of best fit because we know that's the general overall trend of the data. And now we can use it to make predictions rather than trying to read everything literally from the data collected or trying to find that point on the line. So we know y equals 1.11x plus 21, but we are going to replace the x with 52. And when we find that on our calculator, we get y equals 78.72 degrees. So we can write that finally with the correct units. That is our answer, 78.72 degrees. Now in part H, it says, why might it not be wise to trust the prediction made in G? So couple of things here. It did say something about being unusually warm. So I actually want to go back and take a look at our data. And when I look at our data, our low temperatures go from 26 to 45. So they said it was unusual. 52 is not even in our set of data. So when it says, why might it not be wise to trust the prediction, we want to put 52 is not within the range of low temps used. And unusually warm day in April is not typical. And would cause an inaccurate prediction. So, and would cause an inaccurate prediction. So now in exercise 2, it says, generally, the fuel efficiency of a car changes with the weight of the car. A survey of 8 cars with their weights and gas mileages is shown below. So you have weight in thousands of pounds. That will be our X, or in other words, our L1. And then you've got mileage in miles per gallon, which will be our Y value, which we're going to enter in L2. So since I've already walked you through how to do this, I'm going to let you work on this one a little bit more independently and then check back with the video. So in part A, find the equation for the line of best fit using your calculator. So remember, that's linear regression. Round the slope and y-intercept to the nearest tenth. Label what the variables x and y represent in this problem on the scatter plot axes. So currently it says x and y, but we know x is weight in thousands of pounds, etc. So you have to put the actual labels of the problem on the graph. Then you're going to create a graph of the scatter plot for this data. You're going to give a sketch of it to the right, so try your best, along with the line of best fit, and label the scale for your graphing window. So a quick reminder from our previous lesson, look at your data points. For example, the weight goes from 3.2 all the way to 5.5. So I would want to make sure my x-axis gets past it goes to 6.8. So I need to make sure I can at least get all the way up to 7. There's an ending marking on the x-axis and the y-axis. For my y values, I'm going from a low of 18 to a high of 48. So I have to make sure I can reach that on my graph. So you might want to consider a break. I will tell you I did a break in both places. You're definitely going to want to do a break on the y-axis, but I want you to try to practice from yesterday how to make that appropriate scale. And then you'll do the best you can to plot those points and then use the graphing calculator once you have the equation to put it on your scatter plot so you can see where it falls. Then I want to know if the correlation would be positive or negative and which parameter actually tells you this. I want you to interpret the slope and use units in your explanation, which we've done before. I want you to tell me if a car had a weight of 4,300 pounds, what would this model predict? So you're going to use your equation very much the same way we did in part G. And then I want you to go back to the previous lesson and think about if there's causation in this correlation. So at this time, I want you to pause the video and try this exercise because it's getting at what we did today, plus bringing back some of what we did yesterday. And then you can resume the video to go over the answers and I'll discuss with you. Okay, now that you had a chance to try this on your own, we're going to go over the answers. So we already had set up that you should have weight in L1 and then mileage in L2. So to find the equation of the line of best fit, you would have done stat, arrow over to calculate, and pick option 4. And your equation, if we round to the nearest tenth, should be y equals negative 8.1x plus 68.1. So now looking at my scatter plot, as I said to you, I knew I had to get all the way up to about the highest x value was 6.8. So I had to at least get to 7. So I kind of jumped up really quickly to 2 and then went by 0.5s, but marked every other line. And I ended up getting all the way up to 8. As long as you got up to 7, you would be fine. And you see that I labeled the x-axis with weight in thousands of pounds. I didn't just put x. I put what it actually is in the problem. And then for the y values, I had to get all the way up to 48. So I wanted to make sure I could at least hit 50. So I did a break in the graph and started at 15 because the lowest value I had was 18. And then I went by 5s to make sure I got up to 50, which means I would cover all of my y values. Then I took the coordinates from the table, which is just horizontal instead of vertical, and plotted them as coordinates. So 3.7, 38, 4.5, 26, and so on. And then I went to my graphing calculator and I followed the steps from adding the regression equation to my calculator. So I took my linear, I did stat, arrow over to calculate, and 4 for linear regression. But this time, next to store reg, I put y1, and I got that from picking the vars key, arrowing over to the right, y vars, and then picking number 1, which was functions, and picking y1. So that, once I hit the graph, put the line of best fit on my graph, and I kind of used that as a guide to sketch it onto my picture, kind of seeing that it was about hitting the x-axis at 7, and I saw that it kind of went through that point that was at 3.738. So when it says, would you consider the correlation between the weight and the mileage to be positive or negative? We'll actually fill that in together. I'm realizing I did not write that down. So would you consider it to be positive or negative? I can see the picture that if I had, if I was reading this from left to right, when I hit that line, I'd be going down. So as my x is going up, my y value is coming down. So this is a negative correlation. And it says which parameter of the linear model directly tells you this. So I'm going to say as weight increases, the miles per gallon, so MPG, decreases. And the parameter that shows me that in the linear model, that's referring to part A, y equals negative 8.1x plus 68.1, is the fact that the slope is negative. So the slope is negative. Okay, then in part D, how can you interpret the slope of this model in context of the problem? So this is where we get a little more specific. I'm not doing the general description of the correlation, but I'm getting more specific with the number. So my slope up there was negative 8.1, or in other words, negative 8.1 over 1. So I want to say that I can interpret it as negative because as the weight increases 1,000 pounds, its gas mileage will decrease by 8.1 miles per gallon. So this is very much more specific to the actual context of the problem, not just saying the overall correlation and why I know that. In part E, if a car had a weight of 4,300 pounds, what would this model predict? So as soon as I see predict, I know I should use the equation. So 4,300 pounds is the weight. weight was an X value. So I'm going to put in X equals 4,300 in for X, calculate that on my calculator, and when I round to the nearest integer, I get 33 miles per gallon. So that would be the prediction for a car that weighs 4,300 pounds. And lastly, going back to what we had discussed in a prior lesson, is there causation in this correlation? So remember, just because it's correlated some way, positive or negative, does not mean one caused the other. In this case, though, there is causation. A vehicle needs more energy to move if it's heavier. So you need more energy to move more weight, and the way you get your energy for a car is from gas. So this now concludes our lesson on linear regression on the calculator.